Hey guys, welcome back in. Mr. Marone here. Hopefully you guys had a nice break after our Topic 3 test on transformations. You guys enjoyed a little bit of rest over the long weekend, and you're back in here ready to rock and roll on Topic 4. So now we are going to focus in for the next couple chapters on just triangles. We've talked about all sorts of different figures. Now we're just focusing on triangles. Before we get to that point, we have to discuss one concept we've been kind of dancing around a little bit all year. We've discussed the idea of congruence. We used that term before, that two figures can be congruent, or two lines, or two segments, that kind of thing. And we're going to now look at what that means today. So in this picture, we just dealt with transformations, so this should be fresh. They said, suppose there's a rigid motion that takes our black figure and maps it onto our red figure. They want to know, why does that show the two figures are congruent? So if we look closely, it appears that black goes to gray, which was a reflection over the line x equals -1. They gave that to us right here. And then it looks like they did a translation, and it appears it went 2 units to the right and 5 units down. So that was the rule that carried the black figure onto the red figure. If you think about our entire section of transformations, we also called them rigid motions, and we said that in a rigid motion, the figure preserved, let me try that again since I can't spell today, preserved size and shape. Okay. Well, we said that congruence means that they're the same, that the figures are the same. We said that the lines or whatever we were talking about were exactly the same. Well, we didn't change the figure in either of those motions. They were rigid motions. So it preserved the size and the shape. In other words, we were doing congruence transformations. We were just moving a figure, but we weren't changing the figure, so it was staying congruent. So here you got this big definition that any figures that have the same size and shape are known to be congruent. And if you look closely in this figure here, there's a side that has 1 set of tick marks, a side that has 2, and a side that has 3. They relate to each other. And we've got the same thing with our angles, that angle A and angle D have 1 tick mark, E and B have 2 tick marks, and C and F have 3 tick marks. What's really important as we move forward is that means that each of these pieces correspond to each other, meaning that A and D correspond to each other. If we were to write A, B, C, we'd have to write this order D, E, F because they correspond. And that's going to come in handy later on in this section. So take a look at this first example here. They want us to verify that these two triangles are congruent. And they want to know what composition or what combination of motions could we use to map this figure. Well, it appears we're going to have to do at least a flip over the y-axis to start. So we're going to reflect over the y-axis. And I'm going to go ahead and do that. Why don't you guys do the same? And then once you unpause the video, it will be there for you. All right, welcome back in. Now, if you notice, we do have to do another flip. Since C and A and Z prime and X prime sit kind of on each other, we're going to flip it over that line, which in this case is y equals 2. So go ahead and do that. I'm going to change colors, and then we have one more step we need to do. So this is actually going to be a composition of 3 different transformations. All right, welcome back in. Now, as you can see there, I've got y double prime, z double prime, and x double prime, and it's very close. The only thing we need to do is slide it over 1 unit. So my final translation is going to be -1 and 0. And that's going to get me to my figure to map x, y, and z onto A, B, and C. And if we look closely, it does sit right on there. So that concludes that we have congruent figures here. All right, now, just want to show you 2 other examples, and then we're going to be done for today. So in this first one, they want us to identify congruent figures. So they've given us 3 triangles, and they want to know which of those triangles are congruent. Well, if we know congruence, we know that size and shape have been preserved. So what I'm going to do is look at 3 sets of corresponding sides and see if I can match up the congruent ones. So if we look closely, I'm going to pick segment BC. It appears to me that BC's length is going to be the square root of 1 squared plus 3 squared. It goes up 1 and comes over 3. So I'm going to end up with a square root of 10 there for BC. So as I said earlier, we've got corresponding pieces. So if BC are the second and third letters here, that means that FG and KL are going to be the same thing. So if I look at KL here, KL it appears to go up 1 unit and over 3 units to get our distance. So it's 1 squared plus 3 squared, which is also square root of 10. And if I look at FG, it goes up 2 units and over 3 units. So FG is going to be 2 squared plus 3 squared, which is going to give me a square root of 13. So if you notice, BC and KL have the same measure. FG doesn't. So that tells me that this triangle doesn't match and that ABC and JKL are going to be our congruent figures here, since we know that it preserves distance. So triangle ABC is going to be congruent to triangle JKL. The last thing I want you guys to look at is these three figures here. Are they congruent or are they not? And if so, how did they get there? So take a moment, look at them, consider what you can tell, and see if you can create a rigid motion or a composition of rigid motions to complete that. When you come back in, you'll see the answers. All right, welcome back in. So as you can tell on the first one, if we just reflect that puzzle piece over, it's going to match up. So if I reflect over a y-axis, I've drawn in a quasi-coordinate plane. That gives us our reflection there. If we look at the second one, the thickness of my pre-image versus my image are different. So those are completely different figures. We could certainly do some sort of a transformation to set one over top of the other, but they're not the same figure, so it doesn't work for us. And then in the third one, if we were to reflect the figure on the diagonal from top left to bottom right, or the line y equals negative x, we would get our image there. So that gives us our congruence in that third problem. So hopefully this was informative. Bring in any questions you may have into class tomorrow. We're going to live in congruence for a while, so if this seems confusing, you'll have plenty of time to practice it. Hope you guys have a great night, and we'll see you tomorrow. Bye-bye.